Gibbs phase rule is a simple yet powerful concept that we must study. Actually, this is just a review because technically speaking, this will be more into physical chemistry or thermodynamics. So if you have more doubts, go and check those subjects. For now, we will be just covering it because we want to relate the vapor-liquid equilibrium. Okay. The Gibbs phase rule is technically speaking a general principle that governs systems which are in thermodynamic equilibrium. Technically speaking, phase equilibrium. If given F, the total number of degrees of freedom, which I think is the most abstract thing to get, we're going to cover that, and C, the total number of components in the equilibrium, and P, the total number of phases, then this beautiful equation is true. Now, what's F? Essentially, F is the total amount of variables that you will need to set up in order to have a 100% unique system. So let's talk about the equilibrium of water and steam. Number of components, well, probably you know that this is one component, even though it's water and steam, the chemical component is the same. And the number of phases will be 2. So what will be our degrees of freedom? It's components 1 minus 2 plus 2. And we get 1. So what's this? I'm pretty sure that you have heard that the boiling point of water is 100 Celsius. So probably you're wondering, why do we have a degree of freedom? Because we know this is a fixed value. But this is false, or well, not false, not entirely true. This will be at normal pressure. Because if I tell you what will be the boiling point of water at 2 atmospheres, then the temperature will not be equal to 100 Celsius. It will be something 90 something. So as you can see, if I change one variable, or meaning if I propose one variable, then I fix the system, the temperature. Or if I give a temperature, I will be obtaining a pressure. Now, of course, this is a pure substance example, but assume a binary system, which is the one we are interested in right now. We have 2 components, let it be A and B, which typically will be benzene and toluene, or something like that, ethanol and water, blah, blah, blah. So we will have 2 components, number of phases, still vapor and liquid, and the fixed number 2. Once again, if you want to check out where that number comes from, check out your physical chemistry books. Now we got 2 minus P plus 2, which equals 4 minus P. Now remember, vapor-liquid equilibrium has only 2 phases. But if you were talking about vapor-liquid-liquid equilibrium, there will be 3 phases. If you're talking about vapor-liquid-solid equilibrium, you will have 3 phases, and so on. So if we substitute here, we get 4 minus 2 equals 2, meaning that we need to provide 2 variables in order to set up our system. And this hopefully makes a lot of sense to you guys. I got a composition of 1, and vapor composition of 1, and I got pressure. Then if I were to provide all of them, I will have a fixed temperature. The same is true for the system in which we know pressure, temperature, but we don't know vapor compositions. If you were to give me the liquid composition of this material, then by definition, I will be able to calculate the vapor composition. Okay, we're going to see that in the next lecture. But actually, we're going to cover first how Gibbs phase rule is helpful to set up a diagram. Now, before we advance, I don't know if you think it's curious, but we have seen 2-dimensional diagrams, meaning that we only have a y-axis and the x-axis. This is because we are fixing these diagrams into this rule. We want to have 2 axes, therefore we need to fix this. Of course, if you were to add the C, or technically this arrow will be coming to you, the C axis, you will need then to model a 3-dimensional diagram, which is of course not the scope of this course, and typically you will not see 3-dimensional diagrams in the literature.